Welcome back to BSpice. In this session, we'll continue with mastering alarms. In session 2, we'll focus on principles of alarm system design. So, principles in the sense, first we'll talk about the key principles involved, and the second item will focus on the design goals and objectives. So, under design goals and objective, we'll talk about the human and user-centered design and what is the role of the operator and the type of process like continuous batch, all this, and designing for operability. So these are the aspects we will be diving deeper. Okay, let's start with key principles. As you know, friends, understanding human capabilities and limitations is essential if alarms are going to be useful rather than become a hindrance, isn't it? I hope you agree. Right, right. So, whatever is source, wherever it's coming, every alarm should be justified, right? Properly engineered and be consistent with the overall philosophy and risk assessment, isn't it? Okay. Then HMAs. This is also one of the concept. I'll dive deep later in some other session. Okay, so just get to know what is HMA. Highly managed alarm. So this create a higher reliance on the operator response. Okay, and their contributions to risk reduction may go beyond simply reducing a demand on engineered layers of protection. So the point is highly managed alarm create a higher reliance of the on the operator response. So everything left to the operator. That's the point. Okay. Then alarm philosophy should define the use of alert events, prompts, alarms, and highly managed alarms. So these are the key principles we focus. Okay, when we do the system alarm design. Okay, right. To add on further, one of the most important message in all of this is that alarms are provided for operators, isn't it, friends? So, and to be effective, the system has to make sure that every alarm received by the operator requires a response, right? So, friends, in many cases, we have created a self-defeating situation, meaning, where we overload the operator with alarms so that they cannot respond. Then we then address this weakness by implementing additional alarms just in case they do not respond to the first, isn't it? So this is the way sometimes we do. Okay. So here, in this topic, we will dive deep into, like alerts, prompts, events, and also the highly managed alarms, all these. Of course, not in this session. We'll be, focusing on that in the subsequent sessions. Okay. So now in this session, we'll continue with this design goals and objectives. Okay. Okay. As I said earlier, human user center design. Okay. Right. Maybe before that, I want to tell you something. See, it can be tempting to define an alarm system by its technical capabilities and reliability, isn't it? However, its purpose is to support operators. We should not remember. We should remember that. Okay. So the purpose is to support operators, and so the goals and objectives should focus on the user's requirements. Got it? So that is why the human user centered design. Okay. So human centered design is a philosophy that makes the needs, wants, and limitations of the end user the priority focus for design. Okay, so this is critical for alarm system that are intended to support the operators in their critical role. That is the point. Okay, so now um, we will go into the concept here. Okay, to help to achieve the designers should follow a human-centered philosophy. Okay, so what is that human-centered philosophy? Yes, so the task analysis to identify the task the operator performs and the information and the what do you call controls required to carry them. So what I meant here is task analysis. We need to have a task analysis to identify the task the operator performs and the information and controls required to carry them out. Okay, so the task analysis need to be identified. Then development of design standard for the operator interface covering alarm presentation and graphical display on information. So we need to focus this development of design standard on the operator interface, covering them how the alarm is presented, how the graphical display of information. Okay, then important. Design review should be carried out by working party. What is that? Comprising designer, operator, ergonomics, human factors, specialists that reviews the operator interface design through various stages of design and construction and commissioning. So this is very, very important. Then operator involvement in the testing and evaluation of prototype design is also important. And early ergonomics evaluation of prototype design by the purchaser. We need to, do it early actually. Design of prototype. Okay. Then pre-commissioning the operator training in use for the operator interface. Then formal demonstration of the usability of the commissioned interface. That is also we need to focus. And finally, ongoing monitoring and improvement of performance. So these are the some of the activities or maybe we should talk in terms of human user centered philosophy. Okay, to achieve that human centered design, right? So with that, I will mind this session, this topic. Then I'll go into the role of operator. So this is very, very important, friends. Before going into the diagram, I want to talk about a bit. Friends, the role of an operator for an industrial encompasses a range of activities, including process operation, optimization of production, fault identification, coordination of maintenance activities, etc. Right? So the task depends on the process state, and whether it's a normal operation or offset operation or emergency shutdown or planned shutdown or startup or operating mode changes, isn't it? So many of the complex processes, uh, okay, maybe I'll take a step back actually. Okay, so the role of the operator during abnormal situation is very complex, isn't it? Right. So as shown here, in this diagram, the operator response involves several quite different type of tasks. Okay. So as you can see here, friends, so the detect abnormal condition, then he understand the current process condition, then ascertain the future consequences, investigate the root cause, then again action to prevent effects of spreading, then action to correct the current condition, then action to fix the underlying cause, then they monitor the outcome of the corrective action. So these are the some of the role of the operator, isn't it? Yeah. So that is the point. So the operator will often have a lot of data to handle and multiple subtasks to complete them whilst working under time and stress. So it is clear that whilst alarms are useful tool to help the operator, the need for more general task management during an abnormal situation should be addressed. Okay. So one key requirement is recognizing when control of the situation is lost and it has to be managed as an emergency or crisis. So operators may be overwhelmed by the situation and fail to recognize its seriousness or signs of escalation. So in some cases, they may be too proud or concerned about their reputation to ask for assistance. Okay, that may be an add-on additional notes, but just take note of this role of the operator in the alarms. So this is an informative one. Okay, right. Now we go into the other important topic here, types of process basically. Okay, as I said, types of process, being controlled will influence the way in which operators have to react and how alarms are used. For example, continuous, batch, hybrid. It's a mixture of both, right? Continuous and batch. Then geographically distributed process. Okay. So here I want to run a bit, friends. Okay. Just for a continuous process, just remember, friend, just focus. For continuous process, it is usually quite easy to identify normal ranges for critical parameters, isn't it? Relatively small deviation can indicate a problem, and alarms can quite easily be set to provide early indication to the operator, isn't it? Now you say to take a case of this, this is the continuous operation. Plot this guy, it's a continuous operation, okay? And this is a batch one, okay? So for continuous operation, So we can keep this alarm in this range. The safe limit is here. We can keep this alarm in this limit. So meaning relatively small deviation can indicate a problem, and alarm can be quite easily be set to provide an early indication to operator. Okay. So alarm for batch processes here, this guy. See, it should be configured so that they are appropriate of all stages of the process. See, operating condition in batch process vary much more, and so it can be more difficult to provide alarm that indicate a problem at one stage of the batch without causing an unnecessary alarm at another stage. So this is the challenge here. I don't know whether you are getting it. I repeat again. Operating conditions in batch process vary much more, and so it can be more difficult to provide alarms that indicate a problem at one stage of the batch without causing an unnecessary alarm at the another stage. While safety limit should be a constant, meaning like design temperature or pressure of the vessel, the fact that the process is changing towards that limit may be a normal part of the batch and not an indication of a problem. You got it, friends? While safety limit should be constant, the fact that the process is changing towards that limit may not be the normal part, may be the normal part of the batch and not an indication of a problem. So, okay, maybe I'll just add a bit. For example, friends, consider a process vessel. In a continuous process, the level in a vessel may vary between 40 to 60%. Okay, so any deviation from this is an indication of the problem. Alarms can be set quite close to this value. So that is why I put it here, alarm set. Okay, for a batch process, the vessel may cycle between full and empty on a regular basis. So in this case, it is particularly important to specify the maximum operating level. See, this is your safe limit, and what I said is here. So we have to specify the maximum operating level, which would have to be below the high level alarm set point. This is the high level alarm set point. Okay. So it is then important to ensure that operator has enough time to respond to the alarm and stop the vessel being overfilled. So that is what here. You see here, this guy, continuous alarm. So you have a lot of time for the operator to respond. And in the batch, you have also still a little bit time. So that point we need to take care. So that's all about this actually. I want to talk about the process. So it's not like just like that we, put forth the alarm. So alarm depends on the process also. That is the point. Okay, friends? Right. So what else I can add also here. Yeah, I think this is good to go. Yeah. Okay, maybe I only talked about these two processes, right? Okay, maybe I need to talk about the geographical also. Okay, so maybe I'll also talk about this. Uh, okay, alarm for geographically distributed process can cause difficulties for operators who will be remote from the site and plants they operate, isn't it? So during the design stage, each site is often viewed in isolation and requirements of the operator who is responsible for the multiple sites are not considered, right? So lack of data and time lag due to the bandwidth restriction can mean the data is received late or intervention cannot be made quickly enough. So the design should take full account of how operators will handle geographically distributed plant, and every site has to be designed to account for the system and operator capabilities and limitation. So many sites will normally be unoccupied or only occupied at certain times of the day. Okay. So calling someone to attend introduce additional delay also. So even that occurs outside the working day creates significant upheaval to the individual. Probably they may be in a bed sleep when the event occurs, right? And can cause a knock-on effects on the following day if they are not available on work due to the, yeah. So these are the things you have to consider. That is the point, friends. How to consider all this? It's coming up. Especially, I'm planning to have a one separate session how to design an alarm for remote places. Okay, right. So this is about the types of process. Now, designing for operability. Even, I just want to tell you, friend, even if each alarm that is generated is operationally useful in its own right, It will not be effective if a scenario creates multiple alarms and leads to operator overload. So, if an operator is to be effective, it is essential that they can cope with all the tasks demanded of them under both normal and upset condition. So this requires a realistic view of how long it will take for the operator to respond to an alarm and what proportion of the time the operators are required to be in a responsive mode. So observing the physical action taken by the control room operator responding to an alarm may suggest that it takes less than a minute to deal with the situation. They may press a button to acknowledge the alarm, read the description of alarm list, and click on the graphic to make a process change. This is highly simplistic assessment of what a response to alarm really involves. Okay. So to properly diagnose a situation, they will need to access multiple pieces of data, consider their options and take action. So then they need to wait for the action to be effective and consider whether they need to do more. So to achieve all of this on a properly configured system where every alarm relates to a potentially serious incident and event, every occurrence requires a timely response inside 5 minutes would be a challenge, isn't it? And even sometimes it's often impossible due to the time lag between an action being made and the process changing. So taking this as an average time to respond, 6 alarms per hour would occupy the operator 50% of the time. Just imagine, I repeat again, 6 alarms per hour would take 50% of their time actually, occupy their time. So do we really want our operator to spend so much time responding? And if they are, can we really expect them to ever act proactively? It is noted that operators appear to handle alarms at a greater rate than this, but due to poor system design, a lot of alarms they receive do not require an immediate response. Okay, so the point is, if an operator is continuously having to respond to alarms, they will not have the time or motivate to act proactively. Okay, so that is the point, friends. So we need to focus on that also. Okay, see, to add on further, people say that evidence shows that operator can handle a great number of alarms without serious problem. This is really a reflection of current poor performance of many alarm systems, meaning most alarms do not actually require a response. A key aim is to eliminate this unnecessary alarm so that every alarm does require an effective response. So alarm overload responds a significant threat to the operator effectiveness. So strenuous effort should be taken to avoid it. This requires all alarms to be justified, properly configured during design. Once the process becomes operational, performance should be audited, overload incidents should be identified, and steps should be taken to minimize the frequency. Okay, so overloads are typically due to a small number of spurious or badly designed alarms, often known as bad actor. So a review program should be set up to identify these and re-engineer them. However, since most of the alarms that cause overloads tend to vary from incident to incident, the review will ultimately have to cover many different alarms. So techniques to re-engineer alarm range from simple retuning through to complex suppression. That is called alarm suppression, right? So that also we are going to talk in the subsequent sessions. So that's all I have for this key principles of system alarm design, friends. Thanks for watching and stay tuned. Few more are coming up. So the next we'll talk about the alarm system design itself, meaning hierarchy of risk control. We'll talk about the hardware and software and how to design for number of alarms. For example, if alarm is 100, what should be your approach for designing a system? If your system alarm is 100 to 300, what should be your approach? Likewise, we will see how the system size affects the design and management, and also designing an individual alarm and why it is important to provide an alarm. When it is important to provide an alarm. All these will dive deep in the next session. Take care. Thank you for watching. Keep supporting, friends. Your support is our strength. Thank you. Take care. Bye-bye.